Hi, this is Dr. K.Jayalakshmi, and I'm Professor of Mathematics. Today, as you see on my screen, there are few questions related to CSIR net, and these questions were previously asked. And the question that is appearing on the screen is something related to complex analysis. The question is, let gamma be a positively oriented circle which is defined by z belongs to c such that mod z is equals to 3 by 2. Suppose that integral over gamma e to the power of I pi z by z minus 1 into z minus 2 I dz is equals to 2 pi by c, then mod z equals to the option given are option A is 2, option B is 5, option C is 1 by 2, and option D is 1 by 5. Now, when we just look onto this question, it's completely related to Cauchy's integral formula. Here you can see that it is given by integral over gamma e to the power of I pi z by z minus 1 into z minus 2 I whole square dz. This is equals to 2 pi over c. And this reminds us the Cauchy's integral formula. So let us try to revise it once again. Now, to apply this Cauchy's integral formula, we should have a function to be analytic, and it should be positively oriented over a simple closed contour gamma. And suppose that z naught is any point in the interior of a gamma, then f of z naught is equals to 1 by 2 pi I integral over gamma fz over z minus z naught into dz. Then we can also rewrite this one as integral over gamma for our convenience. We can rewrite it as integral over gamma fc over z minus z naught into dz is equals to 2 pi I into z naught. So when we just look onto this formula and the problem that is given for us, we can compare it easily. And then we can see that the whole function value is equals to 2 pi I into f of z naught. And here in the question, the whole function value is equals to 2 pi I into c. This c, we are supposed to figure it out. And the options are 2, 5, 1 over 2, and then 1 over 5. Right. So for us, the given circle is gamma is z in c such that mod z equals to 3 by 2. Elaborately, if we see, you can see that this is actually the center. The circle definition is given by c such that some z belongs to c such that modulus of z minus z naught is equals to r. This is what we have circled. Now we can make the comparison. The z naught or some a, we can also take it as say some a. So let us take it as some a, z minus a. Now the center. So here we don't have any a, so it is nothing but this is modulus of z minus z naught. So we make the comparison. We can see that a is equals to 0. This shows that the center is at the origin. And this one, this 3 by 2 is equals to r. So the radius is how many units? It is around 3 by 2. Now, in this given question, we see that it is integral over gamma, the integral that is given for us, integral over gamma e to the power of I pi z by z minus 1 into z minus 2 by I whole square. Now we have to figure out the singularities of this particular given integral. To find out the singularities of this particular given integral, what we are supposed to do is that we have to equate the denominator to 0. The moment we equate the denominator to 0, one can easily see that the values of z we are obtained as z equals to 1 and z equals to 2 pi I and then 2 pi I. So here we get the pole of order 1 and pole of order 2. The pole of order 1 is equals to 1 and the pole of order 2 is equals to 2i. Now we have to just locate these poles into the circle. So let's try to draw the circle. As I told you that the circle is having the center at the origin. So this is our origin and the radius of how many units? It is around 3 by 2 units, that is greater than 1 and less than 2. So 1 is inside, 2 is outside. This is minus 1. This is I. This is minus I. Okay. This is minus 2. And this is 2. Here somewhere it is outside is 2i. And here somewhere it is minus 2i. Now we try to see that z equals to 1 and z equals to 2i where they are in the circle. So it's easily seen that this z equals to 1 is here. The z equals to 1 is inside the circle, and the other one, that is z equals to 2i, is outside the circle. You can see that this point is outside the circle. So therefore, after locating these singular points into it, now let us get back to the integral over gamma e to the power of I pi z over z minus 1 into z minus 2i whole square into dz. We try to rewrite it. Since 2i is outside, we try to take this 2i to the numerator, and the whole of that becomes f of z. Now, this is integral over gamma e to the power of I pi z by z minus 2i whole square, whole divided by z minus 1 dz. Now, we can now apply the Cauchy's integral theorem to this very easily. Now, we make the comparison of this with this integral over gamma f of z by z minus 1 into dz, where our f of z is e to the power of I pi z by z minus 2i whole square. Now, therefore, integral over gamma e to the power of I pi z by z minus 1 into z minus 2i whole square dz is equals to this 2 pi I into f of z naught, according to the Cauchy's integral formula. Now here you see that this z naught is nothing but it is the one, it is 1, that is the singular point which is lying inside the circle. So this we replace the z naught by 1, and then according to the given condition, according to the given problem, integral over gamma e to the power of I pi z by z minus 1 into z minus 2i dz, this is equals to 2 pi I. Now, if we name this one as equation 1 and this one as equation 2, and we try to compare these two equations, and we see that this c is equals to f of 1. So wherever we have it, we try to replace z by 1 into it. So c is equals to f of 1. This is equals to e to the power of I pi z by z minus 2i whole square. For z is equals to 1. Replace z by 1 into this one. And you see that this is equals to e to the power of I pi by 1 minus 2i whole square, and e to the power of pi I by 1 minus 2i whole square is equals to minus 1 by minus 3 minus 4i, and this is equals to 1 by 3 plus 4i. But according to the question, we are supposed to find out the value of this mod c, and we take the mod c, absolute value of the c. So absolute value of the c is equals to 1 by square root of 3 square plus 4 square. This is equals to 1 by root 25. This is equals to 1 by 5. And this is our solution. If we check the whole thing into the question that is given for us, option D is showing us the right answer. Therefore, option D is the right answer. And thank you for watching this video of mine. Thank you so much.